Okay, welcome to webinar by DAMA Finland and Sytyke. Today, 3 different presentations about the COVID virus. First presentation is presented by Tiia Palvimo and Tero Särkiniemi from Telia. And then Anastasia, Artemyeva and Madhu Singh are telling about how governments have been reacted to coronavirus. And then finally, Sami Laine from DAMA Finland will discuss more about what is decision making, and the context of the presentation is COVID virus. So let's go to the first presentation.
Hi everyone, I'm Tiia Palvimo and I have my colleague Tero Särkiniemi also with me here. We will be happy to answer any of your questions if you can write them in the chat box or raise your hand or something, so that we will go through those all in a one bunch after the presentation. So let's get going. So our topic is to talk about the decision making based on real people flow insights. And why this is sort of a hot topic right now is the fact that we are all facing a new situation where we have a more acute need for understanding the movement of crowds since the mid-March, when COVID-19 hit the Nordic countries with force. And in order to spread in order to prevent the spreading of the virus as well as possible, it is necessary to understand how the restriction measures affect the behavior of the population and therefore the spreading of the virus. And only by doing measurements we can verify that the effectiveness of the measures that we've made, and therefore help make better decisions in the future too. And in the face of a new unknown situation, it is more important than ever to base decisions on information that reflects the real situation at hand as comprehensively and reliably as possible. And all decisions should be made based on using valid and responsible information that represents the whole population. We at Telia have been glad that we've been able to serve this need, the growing need of understanding how people flows change and how they change over time and over space with our Crowd Insights service, and serving both our customers but also the public to inform everyone in our countries how people are moving and how it's affecting the spreading of the virus. You might have heard the term Crowd Insights during this 6 months periods or so, since we've been doing also a lot of media cooperation, and here you can see some of those examples of the news that we've been able to help with, and you might recognize our service from there. But in this case, we thought that we'd have a sort of closer look into what Crowd Insights is, and also some insights of how our customers have been using our service during this year and this strange times that we're all living in. Firstly, in short, what is Crowd Insights? It's the insights of people movements, and it's based on Telia's anonymized and aggregated mobile network data. On the left-hand side here, you can see one example of one of our data, which is representing one random day, each hour representing how many people are spending time in different locations around the city of Vantaa. We have data, and the service has been up and running in Finland since 2018. So during these strange COVID times at hand, we've also been able to share insights on how things were last year or the year before that in the same time. So therefore also understanding even better how much people flows have been changing. We cover geographically all of Finland, but also Sweden, Norway, Denmark, and Estonia. So we've been able to help in all of these countries our customers. We get new data every day. We are not real time. We get new data approximately 48 hours with a 48-hour delay, so that today we have the newest data from Monday. And this is because of all the privacy issues that we want to take into consideration and all the data processing and so forth. In a bit more detail, what is Crowd Insights and how things are generated. So we have approximately 16 million mobile subscriptions. Sorry, that's automated. Subscriptions in all of our countries, and all of those are creating hundreds of events per day, every day. So we have a lot of data that we need to work on every day, and we do it by being GDPR compliant. And going through all of our processing chain, we end up with reports or dashboard visualizations or data export to our customers. And all of this is done by our data insights team and turning the insights into something that our customers can actually base their decisions on. But privacy is of the utmost importance to us, and that's why we also have a separate slide for that one. So we are dealing with sensitive information. Our data cannot be used to identify individuals or small groups of people. We anonymize all personal data already in the beginning of the data processing, and we aggregate all of our data and we extrapolate it to represent the whole population. So instead of giving information how many Telia subscribers have been in some location, we are telling the sort of statistical information of how many people in general have been in some location, for example. And in addition to anonymizing all subscription information, we also create a new random ID to each subscription every night, which means that we can't do this kind of long-term looking into different subscriptions, but every night each subscription is sort of created again, and therefore also being even more precise with the privacy issues. And all of these measurements are done just to be sure that we are doing everything to keep the personal integrity as well as possible. Then a bit, one sort of very simple example of how is our data generated and what do we do out of it, or what do we make out of it? How do we produce those insights? Here are two map visualization examples of one imaginary subscription. So basically one mobile phone moving around the area of Helsinki and Espoo. Here you can see different sized circles that represent each location and timestamp when the subscription has been in different mobile network cells. So it has sort of woken up in the Tapiola Golf area in Espoo, and then spent some time in the center of Helsinki, and then also spent some time around Tapiola area, and then went back where it sort of woke up in the morning. And using all of this sort of information with timestamps and location information for those 16 million subscriptions in our different countries, we can produce a mass information of where do people spend time and where do they travel, and how many trips do they make between these areas where they spend time. So basically we can tell the information that we have in the map on the right hand side, so that we are creating activities, so areas where you spend time in, and then you move between those areas. And by doing that, we can produce the extrapolated statistical information of how many trips are made between different areas and where do people spend time, how many people are in different, I'm so sorry for these automations, how many people spend time in different areas. And we can also tell the new sort of up and coming just right now, as we're speaking, we're working on this routing analysis, which is telling basically how many people flow by an area. So they are making a trip, but they are not being static. So it's something in between trip counts and the activity counts. So you are moving basically, for example, flowing by, driving your car on a road or going by train or so forth. And by combining these different analysis types, we are serving our customers with different spatial and temporal resolution insights. So we can tell, for example, how many people move between different regions or different municipalities. If we look at, for example, the pendling, so going from home to work, and we can also tell on zip code level how many people, for example, spend time there or make trips between different zip codes. And the most granular spatial element is our grids that we will look at in the next slide in a bit more detail. And then on the temporal resolution, we can tell, for example, how many people were in some location, for example, some grid or zip code area during one specific day and one specific hour. Or then we can tell more long-term trends. How are the activity counts or the people counts in different areas? How are they transforming like they are at the moment, since we're all moving and behaving differently than, for example, a year ago? And we can also make averages that, for example, yearly statistics or monthly statistics or so forth. So we can combine different spatial and temporal resolutions and different analysis capabilities with the trips and the people counts in different areas to produce the insights that each of our customers need in different cases. So these are the sort of the parts that we need to work with to figure out what is the best insight to solve our customers' needs. And if we look a bit more in detail with the grids, so this is the most granular that we can get. You can see on the bigger map, the area of Helsinki. The smallest grids are 500 meters by 500 meters in size. So you can see from here that it's not the same as, for example, GPS locations that can be meters. Now we're talking in hundreds of meters or even larger areas. And this is because of the mobile network structure. So the more people in some areas, the more mobile network cells there are, which means that we can get to more granular spatial resolution. But in any case, the most granular is the 500-meter resolution. And on the left-hand side, you can see a map of Finland representing an example of how does the grid size vary. So the largest grids in the sea area and the northern part of Finland are 16 kilometers by 16 kilometers, and then it gets smaller and smaller the closer you get to city centers, where you have the smallest grids with the 500 meter by 500 meter size. So that was in very short explained what is Crowd Insights, how it is sort of produced, and what kind of things we can tell. The next part is about showing visual examples of what we've been doing, working on with our customers now in our different countries where we are operating, to share some insights of what can be done with this kind of mobility data. So we will look at some some examples of how we have been able to help our customers sort of to fight the COVID-19 battle in the last 6 months. It is good to remember that these examples are just for this specific special time that we are living in. Since we have been up and running in Finland since 2018, we also have been doing sort of normal situation customer cases, but now we will focus on the more special time that we are all living in and looking at the different numbers. How is it showing in our data? Here's one example of how travel patterns across the Nordic countries has changed. We are comparing each week into the week number 6, which is in the beginning of February, which was basically the last sort of normal week in the Nordic countries before COVID hit us, because there are the sport vacation times in the February and early March in different countries. So you can see that in mid-March, when COVID-19 hit all of our countries very hard, you can see a huge drop in the trip counts for each country. And you can also see that the different strategy that Sweden took can also be seen in our data, that the trip counts didn't drop as much as it did in all other Nordic countries. And you can also see the changes in the measures that the different countries have made, so that Denmark's trips and Norway's trips started to rise, or there were more trips in those countries because they sort of loosened their restrictions earlier than in Finland. So you can see how the restrictions have been affecting also the movement of people. And you can see the newest situation from last week where each of our countries were. We're actually sharing these insights on our web pages. We can have a look at that a bit later on in this presentation too. So this is something that we are sharing publicly, and you can also look at every week to the fresh numbers. And then some examples of our sort of public customer cases from these times. All of these illustrations are just illustrations. They're not the actual deliveries, but just to give you some idea of what kind of information we can share to our customers. We're helping the Folkhälsomyndigheten, so the Swedish health authority, to understand how movement trends have been changing during this year, to understand which areas are more active, which areas are less active, and then they are combining these movement information to all of their other data sources to understand the overall picture of how does the movement of people affect the spreading of the disease and so forth, making better decisions on how to, for example, change the restrictions or not change them and so forth. So giving them an overall understanding of the whole country's situation, how people are moving, and are they moving differently in different parts of Sweden. We're also helping, for example, in Norway, the Oslo's emergency people. So they need to understand where do people come from to their city, and where do people go from their city, and understand the changes in those numbers, and understanding if some areas if there are people more coming from some other parts of Norway to Oslo than from some other areas. The emergency unit people are also using this information not just to fight the corona crisis, but also to understand, for example, possible future crisis situations, because this is something completely new that we're all facing. So they also want to prepare for something that might also happen in the future, and therefore understand how people would start behaving differently in different kind of situations. An example from Denmark is Statens Serum Institute, so also a health agency, or the Danish Health Ministry. This is also just an illustrative image from Copenhagen area to share some more granular insights of, for example, on the lowest level or the more granular level information, so the grids, and also the hourly information, so seeing the trends not only on daily level, how many people are in some areas, but also the hourly level, and how have the counts changed, and are people moving between different areas differently. So understanding how people flows are changing over time. In Finland, we were working with the Prime Minister's office in Finland to help them understand how people are moving around Finland. This is also a general illustrative example from our trip data, showing trip counts on regional level, so showing how many trips have been made between different regions, and you can also see from the line graph below that the trip counts have gone a lot lower overall in Finland since mid-March. And then we have a more granular or more local example from Finland. We were able to help the city of Helsinki for them to communicate to people. This is a map made by them, not by us, so we're giving all credit to them for making the great map to show people which areas are sort of active, because many areas with parks and forests and so forth were very popular when Corona hit us. So during weekends, people spent more time there than they usually did. So this is how the city of Helsinki wanted to inform people that these are the areas that are very sort of busy. So the more orange, the more busy those areas are compared to normal times. So this was their way of trying to inform people that which are sort of safe areas and which might not be so safe areas. Those were some of the customer examples that we were able to serve. But I also wanted to share some insights that all of you guys can also go and have a look. As I mentioned earlier, we are providing fresh data or fresh insights each week on each of our countries' web pages. So you can see on different areas how trip counts or movement or people flows have been changing. Are they decreasing or increasing? And how that could also help you in your daily life. Example from Finland is you can see the web page there, telia.fi/liikkumisindeksi. It's in Finnish, the web page, but you can see different insights of the whole country, also some smaller areas, but also some city center areas, and then also the Nordic comparison that I showed earlier in this presentation. Just to share the insights that sort of brings valuable information to everyone in all Finland. That was my presentation in very tight way of showing what is Crowd Insights, and then what have we been able to do until now to fight the corona, and also continuing to help our customers to sort of make all of our countries safe and stay safe and prevent the COVID from spreading anymore. Thank you very much for this, and we can now have some of the questions if there are any.
We have one question to the last presentation.
Sure, I can also read it here. So
okay, yeah.
From which countries do we have data? So we have data from Finland, Sweden, Norway, Denmark, and Estonia. So those areas where we have Telia's network.
Okay, let's move to the next presentation. Satu, Anastasia, and Madhu.
Yeah, it seems right now that Madhu is on her way, so she's still not here. So I'll start alone, and let's see if she makes it. We know already from the beginning that Anastasia doesn't have an opportunity to join. Last academic year, I and Anastasia and Madhu, we studied at Arcada, University of Applied Sciences, and the program we took was Big Data Analytics Specialization Studies. It was 30 academic credits, and it was like mathing, Python, and visualization, and we also used did counting with big data, and I think it was quite an interesting program. At the last part, or let's start this first, I work at LTC Otso as a business consultant in and with business analytics. And Madhu, who is coming, if she managed to do that. She was studying at the same program, and now she's doing the Master of Engineering at Tarkkala, which is on top of the Big Data Analytics specialization studies. She's from India and has worked in banking and finance there. So our last project was to investigate how the situation has been developing in European countries that implemented the same measures in order to examine the effectiveness of the measures. So there has been done a lot of different kind of machine learning projects with open COVID data, but this kind of approach wasn't made at that point, or at least we didn't find any. So our research scope was just European countries because there is lots of data and lots of work with the data because the open data needs to be cleaned. You need to understand the data. So we took just a piece of it and decided that it would be nice to have Europe because we live here. And then we wanted to know what is the impact of the governmental measures on the spread of COVID-19 and how the situation has been developing in the countries which implemented the same policies, and has there been differences. So we had different kind of data sets. We had a data set which contains government measures, and that data set contained measures worldwide, and there is the data set's name. Then we had a data set of confirmed cases, and it contained daily time series summary tables, and also we had a similar data set about the deaths. Then we had country information, country population was important, and also the population density. As I said earlier, there was lots of cleaning and with the data. There were like several rows of the same country, and that wasn't expected. So when we were doing the project, we needed to clean the data quite a lot. So our analytical approach was the one that first we clustered the countries into 4 clusters, and that was done based on the measures and measure categories, because there were a huge amount of measures. So we tried to keep it simple because we did have only like 6 weeks time, and like I was all the time working, so we did this like at free time. Then we took the data which we had numbers on, and we did analysis of the trends for European countries within the same cluster. So at this presentation, we chose only 2 clusters of the data. And the reason why we chose these 2 were that the cluster 0 contained Italy. And like we all know, they had a huge curve in the beginning of COVID. And another cluster is the one where Finland is in. And when we are looking at this confirmed cases curve, we see that the number of cases in Italy is high rising, like also in French and Germany, and the other curves are quite low. But when we are looking at simultaneously at the number of population, that necessarily don't tell the whole truth about it, because there is much more people living in Italy than in Luxembourg, for instance. But we see that it high-rised. Then we started to look at the measures and to see how the measures has had an effect. And in this first slide about the measures is the schools closures. And we see that Italy is the first one to close the schools, and then all other countries did that almost simultaneously. And we also see at this same slide the growth factor going down in most of the cases. There is a bit of a rise in Germany, but we do see that the school closure did have an effect. We can think so. Then we have the border closure, and on that one we see it quite a similar way. Italy was the first country to close its borders, and first I think they closed it only for Chinese persons or travel from China. But we see here also that other countries did the border closure almost at the same time. And it seems that that also had an effect. Then we have the cluster 2, where is also Finland. And we see here that Spain has had similar measures than in Finland, and its curve is quite high. The points, I think, were the first cases reported in each country. And we see that like the first cases, the curve is very low at the point there is first cases, and then the curve is going up. And like in the cluster 0's case, Spain has a larger population than Finland, for instance. So the curve is so high because of that. Then the same slide about school closure. And here we see again that countries were learning from Italy, probably, and they were closing the school at the same time. And the curves went, we can see that the curves went down elsewhere, but in Spain. And in Spain, I think that it stayed, that it didn't went higher anymore. And here is the same slide about the border closures. And here we see that again, the countries were closing their borders at the same time. And also we see that it seems to have an effect. Well, then what we were thinking about, all what we learned, was that the development of pandemic depended on countries' characteristics, like population density, culture. Like in Italy, families are or children are living at home at quite long. They are way over 20 when they are moving out. They tend to hug and kiss on cheeks more than in Finland. And when there is a higher population density, there isn't so easy to keep distances, and we Finns tend to keep distances even if there's not a COVID virus ongoing. Then we also see that first minor measures had little effect, but larger measures like border closure, school closure, lockdowns had an effect. And measures also take time to have an effect. It's like if we look to curves, it's like 2 weeks after a measure has been taken, the effect shows. We also learned that it is important to take measures early, and countries can benefit from experience of other countries. And we see that that other countries other than Italy took the measures at the same time. So we see on that we Finns benefited from the Italy's experiences. And depending on country characteristics, some countries might need larger measures than others. And when we did this study, it was April, May. We thought then that it would be interesting to observe what will happen when the countries are opening up and reduce the amount of measures, and how the trends will develop. And also we were thinking about that, can this research on European countries help other countries like in South America? Because we were seeing that the numbers were rising at that time. I was thinking something else what I could have said about this, but now I don't remember anymore. Yeah, that was the that my idea was that we have now, when the time has passed, we also have learned about the virus, about the that we don't need to do such a big restrictions, that we kind of know that it is enough to do smaller things, that we don't need to shut down the whole sort of whole like Uusimaa, like we did, that maybe smaller measures would be enough. We also know that children don't spread the virus so much, so maybe the school closures weren't necessary. We'll see, but it would be interesting to further analyze the situation now. Sort of. Oh, here is a demo, but I won't show the demo because I don't have the Python installed on my work laptop. But I think that's our presentation, and I will answer questions if you have some.
Thank you. No questions at the moment, but I think we can wait just a little bit more if there comes any.
Okay, can you see the presentation?
Yes.
Okay, so thanks. I'm Sami Laine, president of DAMA Finland, and I have this provocative topic today. what if the whole world is actually bad in data-driven decision making? And minor thing like purpose of life. So when we go back to something like half a year ago, the world learns about this new virus, COVID. It's coming from China, and cases start to come up everywhere in Europe, USA, and so on. We hear more about rising counts of diagnosis and deaths. And then the governments start to do something about it. They end up even closing the whole countries. They close the traffic. They close the businesses like pubs, restaurants, and they close the workplaces, and the whole societies are being shut down. And all of these have been done because they have gotten facts, they have gotten some kind of data and made decisions based on facts and simulations. And of course, these kind of drastic measures, reactions, they have a really big impact to our life. And first economists start to calculate how big issue this is going to be for us. And there is different calculations, and we are currently getting more and more accurate understanding what actually happened in economic terms. But the main thing is that because these lockdowns, business closures, and changes in behavior of people, we have lost a lot of economic value. The magnitude is actually, if the global GDP, gross domain product, is something like 5 to 10%, like it has been estimated, it's $5 to $8 trillion, thousands of billions. It's something like an average of 4 to 6 times the whole GDP of Scandinavia. It's like Finland, Sweden, Denmark, Norway, Iceland, all had been shut down in a black hole, vanished, and that 4 or 6 times. It's something like 1/3 or almost half of the whole Europe area GDP. It's almost the same like Latin America and Caribbean had vanished. The magnitude of these closures is massive. So then some people started to think that, are these efforts really proportional to their costs, side effects, and alternatives? For example, Professor Lilrank started to calculate that this COVID strategy doesn't make any sense. If the simulations are correct and we save something like 3,000 Finnish people, and if you compare how much we are investing to other kind of diseases, typically in Finnish healthcare practices, the cost of quality of life year is something like 30 to 50,000 for quality of life year. But now in the COVID, actually we are spending 10 times more for each saved year. And in United Kingdom, for example, there is a statistics that actually the home violence increased 100%, and for example, the cost about home violence increased 100%, and so on. And then in the first 3 weeks of lockdown, 14 women and 2 children were murdered. And this kind of measures have also a lot of other impact than just economical impact. And there's a lot of information by United Nations and Amnesty and other similar organizations about these differences, what lockdown, how lockdown changed the societies, how much violence actually increased. But we are not seeing these figures in the news. So the questions comes that actually, what if we save 1,000 lives from COVID, but we kill 10 times more people elsewhere and ruin even more lives? And not only that, if you compare how much we are using efforts to combat COVID, what about influenza? Many medical experts have talked about these different diseases like influenza or malaria. For example, every year malaria kills 400,000 people. And it was only something like 10 or 15 years ago that malaria killed 1 million person every year. So we are now using thousands of billions to save something like maybe 1 million person in the world. But we are not willing to pay a couple of billions, 2 billions to save those malaria people or some other diseases like cholera. So we are actually using massively more money and efforts to combat this COVID than we are actually combating diseases that are maybe almost as bad as COVID. But the thing is that we actually don't know how bad the COVID actually is. And then some people started to talk that actually we have a data problem. I don't go into the details of these, but for example, in USA, there's a couple of good articles that you could check from Dr. Redman and Davenport and others. They have written quite good articles that how we actually should get much better data to actually make valid decisions, and we would be in much better position to select correct measures and select correct reactions, and we wouldn't be wasting money due to uncertainty or problematic data. And also in Finland, there has been a lot of talk that actually this bad data can lead us to do wrong things, and it can make focus the public speech and our government actions to wrong directions. And for example, the National Institute of Health and Welfare, the AGL, they have been a couple of times in news because they have had some data quality problems. Some people have apparently risen from death because the death counts have been going down. And these are typical statistical errors. The same data has been sent twice to National Institute, or they have changed the definitions. What is COVID episode? Is the same person being treated in the 2 different places for COVID? Is it 1 case or 2 cases? Small details, semantic details that have really physical effect to the statistics. But these small changes have gone into the news. So what we know is that our data actually is incomplete. It's inconsistent, incorrect, and it's heavily manipulated. So the question is that the impact of the COVID is massive. And we have that data that we have been using to base our simulation and analysis. What if we had better data? Could that better data have saved something like even 1/5 of the all losses? Like saving the GDP of whole Scandinavia. And only 1/5 of the things would have been done better. We wouldn't have to, well, we wouldn't have to be perfect. Just 1/5. And what if the data is so bad that it's, or we have been selecting completely false reactions? Did we just throw away half of Euro area GDP because of this false data? Or did we actually just save 1 million Western elderly and we are actually killing 1 million developing country children and parents? Because here in Western world we have social health, we have social care, health care, we can work from distance, we have actually savings. But in many countries like Brazil, India, there is actually billions of people who don't have these possibilities. And when the GDP of Finland, USA, Germany, Japan is actually dramatically lowered and they stop buying stuff from developing countries, our lives are actually having much less impact than those who are living in the developing countries. Their problems are much bigger. They don't have such healthcare services like we have. They don't have ability to work in distant workplaces. So to actually analyze this whole thing, we have to go back to the fundamentals of data-driven decision making. What's actually going on in this situation? And I want to raise a couple of small examples. What's going on? So there's different countries, and some are doing better and some are doing worse. So we have these two countries, and it looks like both have gotten some COVID cases. They start to diagnose COVID patients, and then the diagnosis, they have done some measures, they have closed some business, and then the diagnoses start to go down. So they are winning the virus. Which country is doing better? The problem is that in reality, this is false picture. They are just looking for diagnoses. And the first country, they are not testing asymptomatic patients. They are testing only those that have symptoms. They have symptoms like cough or temperature, but they are not testing everybody. So in reality, even if they see that diagnoses are going down, in reality, they are winning because everyone has already had it. And the other country, actually, because they are testing asymptomatic, they can see the difference. Yes, we are actually winning this because they also notice these asymptomatic COVID cases. So they are actually controlling and suppressing when the other one is living in complete illusion. So, and to detect difference between these different countries, to detect difference between highly and mildly contagious virus, you need to test massively and also these asymptomatic populations. It's the strategy like South Korea. It's the strategy like Singapore. And the problem is that in the beginning, we didn't know which country we are. We just saw diagnosis, but we couldn't actually understand the whole situation. we didn't test enough asymptomatic cases. We didn't know if these diagnoses are the real cases and how big amount of people are actually having COVID condition, but they are just not having any symptoms of the disease. And the other one, again, which country is doing better? The first country, because they are not looking for antibodies. They think they are doing well and they are closing their businesses. They are closing their whole economy. But because they are not looking for antibodies, they don't understand that actually everybody is already immune. They are doing completely wrong things. This controlling just wastes efforts. And the other country, because they are testing antibodies, they can see that yes, our diagnoses go down because we are controlling it, and there's some slight antibody increase, so small amounts of population have become immune, but not everybody. So in reality, if you are in a country like this second one, you are actually controlling and winning the virus. If the case is like the first one, you are actually just wasting all the money. You are just wasting all the efforts. And to detect difference between this kind of common and rare disease, you need to measure the antibodies. Diagnosis data alone is ambiguous. You just can't do any valid decisions based on amount of diagnosis unless you understand the level of antibodies. And the problem is that across the globe, we still do not really know which country we are. In some countries like Finland, we know much better, but we still really don't know virus enough. And the third case, again, these countries are winning because the COVID deaths are going down. They see statistics of COVID deaths. But in reality, the first country, they think that they are winning the COVID virus because they just don't calculate all the deaths. And in reality, people have died in masses. And this case is more like Italy in the beginning of the epidemic. So, for example, in Italy, it has been estimated that the total death rate of the cities became twice or 3 times more than in the average years. But the COVID death rate is much lower. Actually, the measured COVID death is only 1/3 of the real death that COVID has been killing. The difference between not detected COVID and the detected COVID, it's massive. And this is one of the biggest problems in countries like in developing countries that don't have proper population control, population statistics and healthcare statistics. They don't actually know how many people die. They see only minor amount of deaths, and these are the COVID deaths in the hospitals. And this second country, they are actually winning it because people are not getting and they are not dying any more than the average years. So they are actually controlling it. And again, to detect difference in between, if you are really controlling or losing the virus, you need to understand and measure the total death rate. COVID death is meaningless unless you know the total death rate. And most of countries still don't know these. What are the total death rates? and we are not seeing much news about these total death rates. Everybody is staring about statistics about diagnoses and deaths, but they are only one small part of the whole picture. So to really understand this COVID virus and to really make valid decisions, you need to actually know all the variables. So first is this how it spreads, how the virus spreads from people to another. We need to know the actual infection rates, but we don't know because we don't test the asymptomatic. We test only those who have symptoms and only few of those. And we don't really know about antibodies. And in news, we are almost completely focusing on hospitalization and death rates in the hospitals. We don't really know the total mortality rates. And even more or less, even less we know about quality of life years. For example, only recently we have been starting to read about long-term effects of the COVID virus. Even if the whole virus might have been almost asymptotic, you don't really know even that you really had COVID. But that might cause some long-term problems to your lungs and other part of body. So the quality of life can be affected even when you have just had an infection that you don't even know. And the episode, we have been following mainly how long episode this COVID is, but we actually don't know much what is the mechanism of the transmitting and can you get reinfected? How long the antibodies actually protect you from new infections? The way how these transmit from people to another and the reinfection rates are practically unknown currently. So in public media, we are following mainly symptomatic cases, diagnoses, hospitalization and death rates, and these some kind of duration of how long typical case lasts. But actually, these are really tiny part of the disease. And because we lack these other variables, we can't understand the whole picture. We can't. We probably can't do valid decisions what should be done to COVID. And the problem is that even these small things that we know, they are heavily manipulated. For example, in Russia, if you die to COVID, they have completely different interpretation when you are written as a COVID death than in Finland. And in many countries, they hide the COVID death because they don't want the public to know. They don't want other countries to know how bad the situation is. Or then many countries, they simply don't have any means to do diagnosis. They don't have any means to test antibodies. They don't follow quality of life of their population. There is no way that many of the developing countries can actually track what is going on in their population health. So our picture is really tiny part of the whole problem, and it's really biased problem, or biased perspective to the problem. So the challenge is that we still do not know what kind of virus this COVID-19 is, because we lack high quality data and understanding of this whole phenomenon. So I made this kind of small table to illustrate what this means in practice. So in the left side, you have a couple of different slots how fast this virus could be to infect people. So some viruses are really easy to infect, like the flu virus, and COVID seems to be more like a flu virus. It's not like the SARS that was much less eager to infect other people. And then there is some very slow diseases to infect, and some are in the between. And then some viruses are mostly harmless, like the common flu. The influenza is much worse, and the COVID might be and seems to be quite a bit more dangerous than influenza, but it's still not as deadly as some of the other previous coronaviruses have been found. So some are harmless and some are always deadly. For example, the couple of the earlier epidemics, something like 10 years ago, the death rate of, I think it was SARS might have been something like 50% death rate. I don't remember actually which one of these were, but some of the coronaviruses have been really deadly viruses, and COVID luckily is not such a dangerous virus. The problem is how fast an unknown virus spreads, and all these, because we are seeing the diagnosis, we are seeing the death, but we don't know the whole picture. So we don't know if these are outliers or is this a disease that will kill everybody. And in reality, there is much more dimensions like these. These are just 2 dimensions to illustrate the problem. And when we learn more about COVID, we start to understand that what kind of virus COVID is. Is it mostly harmless and slow to infect, or is it fast to infect and always deadly? And depending on the characteristics of the virus, you need to do different kind of reactions. You have to react to it differently. So understanding this whole context is important to select the optimal reaction. So we have different ways to react to unknown virus. We can prevent it, vaccine, distancing, and protection like face masks. Then we have different treatments like medicine to lower the symptoms. We can use hospital care and even intensive care in life-threatening situations. We can control it, try to control it by first diagnosing, then tracking the cases and isolating the cases. And we can make impact to societies by first informing, then recommending, and later commanding rules to the societies. But how we are going to use these depends in many things. And there is globally massive differences how different countries and regions can use these different measures. And even then, the measures in one country will affect the other countries. So for example, closing the borders of Finland might be meaningless if Italy doesn't close the borders and everybody in Italy had a disease. So these both countries actually has to do the same kind of controls that these in combination these start to have a better effect. So when one country doesn't do their work, it can affect really dramatically to other countries and so on. And here is complex illustration what I try to say here. So I divided these same table that was in previous screen to two different parts, each block. First, you can focus on looking for diagnoses, and you can look for antibodies. And when you start to analyze what that would mean for different type of viruses, if this virus is really harmless and it's just very fast to infect, it's really not it's really waste of effort to spend time to diagnose people. It's waste of billions euros to try to diagnose virus that is harmless and just infects everybody so fast, because you just end up trying to diagnose people who have already gotten it. Everybody already had the easy virus. They have antibodies, but if you don't check the antibodies, you just keep up re-diagnosing and diagnosing and diagnosing these people that are already involved. And if it's really easy and slow to really harmless virus and slow to infect, you actually waste time because you don't find antibodies because it's so slow to infect everybody. You waste money when you try to diagnose it because, well, it has so minor impacts and hardly anyone gets it. But on the other hand, if you start to notice that this actually starts to kill people and people get really big health problems due to it, the more important it is to diagnose and treat fast. But that's not enough that you know that, okay, this disease can kill and this disease will cause big health problems, because it still might be that it's really slow to infect, or it might be really fast to infect, and this has massive differences how you should react to it. If it is very fast to infect, then you actually have to do massive lockdowns, and you have to lock down even healthy populations, because you just can't afford to let it infect anyone. You have to close down the cities and the countries, the businesses and so on. And the same way, but if it's really slow to infect, you might not want to waste billions of euros. You might not want to waste globally trillions of euros. You don't want to close down the whole GDP of whole Europe, because you could actually just isolate the infected ones and try to let other population live in a more normal life, because it's still so slow to infect others. But the problem is that you still, even if you see people dying, if they get health problems, you still don't know if these are outliers, or are they happening every time that someone gets an infection. Therefore, you have to check also the antibodies, because if there is a low amount of antibodies and it looks like a large number of people who are diagnosed will die, then you are dealing with very deadly virus. So you need to test not only symptomatic cases, but also asymptomatic cases, and you need to check the antibodies to understand if this is harmless virus and you are just seeing the worst outliers of the cases, or if this is really a deadly virus that seems to kill almost everyone who gets it. And the problem is that the COVID virus has been really problematic for healthcare analytics, because it's not always deadly, but it's not either harmless, and its infections methods are really problematic. It seems to be that it infects some people differently, and some people are like super spreaders of the disease. Some people are not so dangerous when you are with them, but some people actually can give the COVID virus to hundreds of people in a single one night. So there's a difference how people actually transmit the disease. And this has created a problem that it's really hard to track and understand which kind of virus COVID is. Is it how easily it infects and how dangerous it really is? And especially when we don't have all the data about antibodies and asymptomatic cases, infection rates, and so on. So the lessons for data management professionals. Because we are in the webinar about data management, and this is also very important topic for DAMA Finland. So what is the real purpose of data management? It's helping to make sense of reality, like the COVID case. Data management tries to help people, experts, and societies to understand what is going on, so they can do valid decisions based on data. And the most important is to understand and frame this problem context. It's most important to understand that what kind of variables are playing in this whole picture, what kind of variables affect the system and phenomena called COVID. And after we understand the variables, then we need to focus on the meaningful measurement. We can't just focus on, for example, diagnosis, but we should focus measurement on all the relevant questions. What are the levels of antibodies and the infection rates of non-symptom, these asymptomatic cases, and so on. And when we have found out our priorities, what are the most relevant measurements, what are the most relevant variables, then we need to productize this information production process. We need to start to collect these data. We need to start to manage the data to actually transform it to a form that it lets us to do some kind of decision. Like, do we lock down single person? Do we lock down the whole city, or do we lock down the whole country? Because it depends on the case. If it's easily transmitting disease, you might have to lock down the whole country. If it's not so easily transmitting disease, it's you can actually just isolate the patients that are currently diagnosed to have the COVID. And in reality, it might be something in the between of these. But the problem is here also that because it's in the middle of these opposite choices, the difference, even the small gradual differences between the opposites, can be actually the decisions that will cost billions of euros, trillions of euros. So, and for data management professionals, there is a need for us to really understand this magnitude of these data challenges as a part of wider socio-technical system. We should not actually care too much about individual data quality problem like National Institute of Healthcare somehow lost 10 diagnosis cases, or they changed the definition of the cases, and the diagnosed cases of Finland went from 500 to 300. That's in the big picture, these errors are actually quite meaningless. So these data entry errors and statistics, they can get easily attention because it's weird that somehow Finland's death, people who have died goes down in the statistics. like some people have just became alive again. But in the big picture, this kind of small data entry errors or statistic errors are meaningless, unless, of course, the whole production process is truly broken, and there's a really big and systematic and massive data entry problems. But the good case in these are actual errors, and you can fix them by fixing the error and by fixing the production process, because everybody understands that these are errors and they should be fixed. And so by this I mean small and local, I mean this kind of idea that everybody understands them as a problem, and they understand that this should be fixed, and they are more like a local problems. The second more problematic and wider problem is semantics that are not so often talked in the news or other discussions. And in COVID, the semantics of COVID, there's a really big challenges globally. Like I mentioned, the Russia and Finnish version, who has died to COVID? How much different countries clean up the statistics? Because somebody reports those cases that have died directly to COVID. For some countries, it's enough that they have had COVID, but they actually died to side effect of the COVID, and this is COVID death. But not every country agrees on these definitions. And then there's also that in many countries, if the side effect or the reason of the death is so far away side effect of the COVID that they don't count it. So there's a really big differences what is calculated as a COVID death. And this is not only about death, the same is about who is actually COVID, what is the COVID rate of the country. There's different interpretations, and there's a different kind of measurement problems also. So the even more challenging and wide problems are these actual measurement problems. Even if you can agree on the semantics, there is things like we simply don't have any means or correct instruments to measure antibodies. We don't have good instruments to do diagnosis. Current instruments, the COVID tests, have error rate of 20%, and that's a massive difference. That's a massive error rate. And antibodies are even harder to measure and even more problematic. And then there's many countries simply don't have money and resources to do diagnosis testing or antibody testing. So the measurement errors in different countries, they are currently really huge. And these are actually much more challenging and wider problems, because you can't fix this kind of problems by just teaching somebody to enter data in a better way, or you can't just build a small application to fix the data, because these are the whole societies are incapable of measuring. The whole societies do not have any means to actually measure their populations, or nobody even in the whole world knows how to measure antibodies and so on. And then there is even more critical and massive problems, these systemic and contextual understanding, because we data management professionals, we are usually put into the box of data management people, data managers, and we are giving data, and we should try to keep it in a correct form, try to make it good, and that's our job. But the main things are actually in the contextual problem, what we are dealing with in the real life. So the critical things are like, how do we actually understand all the variables that affect the COVID? I have been just slightly mentioning few of the variables, but in reality there is hundreds more different variables that should be taken into account when you consider the whole socio-technical system of managing epidemic. And these problems are much more critical in modern society. And for example, in these biases and systematic errors have become actually slightly more popular nowadays because artificial intelligence has been getting so much attention, and everybody has heard about biased recruiting robots or artificial intelligence who just enforces the current biases in recruiting policies, or how artificial intelligence drives through people because there is some kind of black box problems in the internal structures. So this kind of systemic and contextual system dynamics is actually the biggest problem. And in COVID, we can see it by our biased focus on diagnosis and death. And we are not paying enough attention to these different variables like antibodies or actual infection rates, or the problems of measurements and semantics between countries. And these small and local problems, well, these are mostly things that data stewards, engineers, analysts, and scientists deal mostly, because these are the things that we can affect. We have tools to fix these, but we don't have tools to fix societies, at least not directly and personally. Hopefully we can influence societies, but in our daily work we can mainly fix these small and local problems. Then some people are data managers and advisors who try to deal with these semantic and more wider problems. They try to discuss and make sense of these different perspectives and so on. The wider problems, the high-level data officers and evangelists who are actually making the data strategies, they can actually solve these problems because they influence the decisions. What kind of investments we are doing, what kind of systems and measurements. Do we put 1 million to diagnosis investments, or do we put 1 million to some other kind of thing? But most important is that these business experts and advisors who deal with the actual business context, they problems of understanding the system as a dynamic system and the variables. These are the most critical persons. So the final questions after this presentation. What if the world really is bad in this data-driven decision making? The problem is that if we are bad in it, we are wasting massive amount of wealth, health and happiness for generation. Because this impact is so massive. It's actually GDP of Scandinavia multiple times. It's something like the whole Latin America was shut down and destroyed by black hole. And a lot of life quality lost by other people. But luckily, we have a lot of real experts who are actually studying these antibodies, death rates, and other less popular variables. The thing is mostly that we just don't follow these in the news. The picture painted by news is biased, but there is a lot of medical research being done to these other issues. There is a lot of medical experts who have much more complex simulations. They understand the system in much more detail than these typical data management and analytics people have any idea what they are actually studying there. But that leads to the main case. The purpose of data management professional is actually to help these business experts, these domain experts, to solve their contextual problems by enabling these valid conclusions. So, we data management professionals have a purpose. We are here to help others save the world. We might not be the business people who actually do save the world. For example, like doctors save the people's lives in the hospitals, or health administration saves the societies, but we are the ones who help them to save the world. We have this Data Management Professionals Association, DAMA Finland, and we are having a yearly meeting in about 20 minutes. And if you want to join the association and help to save the world, or help others to save the world, then you can send message to us or join the LinkedIn page and so on. And if there is no questions, I can tell a little more about DAMA Finland and what it is and what DAMA in general does. Now you should be seeing the DAMA Finland presentation.
Yes.
So in general, we are a Finnish association. Our rules are only in Finnish, but we are a Finnish chapter of a wider DAMA international network. We are non-profit and technology and vendor independent association. And the purpose of the DAMA Finland, well, like I told, we are here to help others to save the world by enabling the data management and management of data as an asset. And as an association, we try to advance best practices of data management, along with the network, TIVIA network. And therefore, we arrange different kind of trainings, seminars, and events, and take part in TIVIA activities and other DAMA international activities. And I think that the main thing is to understand the whole DAMA network, because that's the part we are, and that's the whole mission, our mission to be part of the DAMA network. So DAMA is a global association of 4 technical and business professionals to advance these concepts and practices of information management and data management. And the vision is to be the central resource and the network for people who want to be part of information management and who want to learn about information management. And the DAMA International is actually quite a huge network. It's global in every continent except not in Antarctic, but in every other continent we have a chapter. And this is mainly the most active chapters are in USA and United Kingdom, in In Europe, there is also a couple of other European chapters that are really active, but mainly it's USA and Europe. And the main things that the DAMA International has done are these DMPOC and CDMP. The DMPOC is actually a book. It's a body of knowledge. It's like a PMPOC for project managers. Data managers have DMPOC, and it's a book that tries to capture the most essential information about data management. And here's a couple of different goals that DMPOC tries to be. So it's a collection of standards and definitions, practices, guiding principles, and things like that that can be used in data management context. And as a part of wider picture, I think this is really important to understand. So DMPOC is actually really critical piece of data, of actually critical piece of leading and managing organizations. Like my presentation, I emphasized the actual business context. So actually there is a business analysis, BA-BOC type of methods and knowledge that must be used and should be used while building epidemic management capabilities across societies. But data management helps them in these issues that are related to managing data as one critical resource, and how to build things like analytic systems and how to manage information flows across organizations and so on. But of course you need project management knowledge to actually build something, how to manage building complex systems, and then IT service management like ITIL, how you actually manage the operations of the systems and so on. So DMPOC is part of critical part, and it has links to different other knowledge areas. And the whole DMPOC is based on the idea that there is some kind of environment that affects, and we live in an organizational environment, but the main thing in the organizations and data management is always these central goals, visions, missions, and the business context, where what the organization is actually for, what it tries to do, what it tries to become. And in this context, there is a different things that affect its capabilities to achieve these goals, organizations, tools, activities, practices, and so on. So the DMPOC is built on the idea that these different things should be managed in a more systematic way, and the DMPOC describes these different activities for each topic. And the topics, the knowledge areas, are divided based on professional skill sets and professional knowledge areas. Typically, one data management professional cannot know and understand and manage all of these. They specialize to some of these. They are better in a couple of these. But of course, everybody should understand at least the fundamentals of each of these, because every knowledge area is linked to each other. And based on this data management book of knowledge, DAMA International has built a certified data management professional certificate program. So you can actually get credited and acknowledged, but to be a real professional, you are verified to have relevant skills and understanding of the topic. And this is one of the few certifications that is technology and vendor neutral. So this is not about learning to use a tool by some mega vendor or some minor vendor. This is generic practices and methods that are applicable to any situation, in any context, to any tools by any vendor. And here in Finland, you can actually buy the CDNP training. I'll try to find it here. By Ari Hovi, and Ari Hovi has regularly, like in I think in 2 weeks, they have a next training by Chris Bradley, the fellow of DAMA International, and the main author and the main developer of the whole certified data management professional program. So he's the main person who has built the certification, coordinated the certification development, and he's training how to actually, he's training the content and training how to pass the certification. And if you want to get the certification, you can go to check Ari Hovi pages. Okay, I think we are ready to close the event.